OpenTelemetry and observability. Woo! Yeah. All right, cool. So, hi, I'm Josh. I think I have an intro slide. No, I don't. So hi, I'm Josh Lee. I work at Altinity. I'm a developer advocate. Before that, I was a product manager at IBM Instana, which is an observability platform. Specifically, I was our product manager for OpenTelemetry, Prometheus, right, like all of the open source integrations. So while I'm talking today, this is kind of the question that I want you to keep in mind. It's really just about how do we debug our applications. At the end of the day, that's the goal of what we're trying to do here. Everything else is in service of this. So this is how we debug our applications, right? Talk's over, done, okay. No, like if you're in this room, you probably have enough experience to know that this is the easy part. The hard part is getting to here. The hard part, right, is like lowering our mean time to Google. Or now, right, like probably like mean time to ChatGPT or whatever your preferred method of searching the internet is now. So we need to get to this point. We need enough information to understand what went wrong and locate the actual problem in our massive production systems. So really the question is, how do we debug our applications at scale? And for me, coming into the observability world, this meant just doing a lot of reading, right? You're just reading logs, trying to correlate things, trying to correlate events and timestamps and IDs, and figure out the chain of events that led to the error message that the user's seeing, or the corrupted data, or whatever the problem is that you're trying to debug, right? So, logs, like that's painful. That's a painful process. And I'm going to introduce some tools that make that less painful, specifically distributed tracing. But I also think that logs kind of like don't get enough credit for how powerful they actually are. So if we look at a typical request log here, right? Like everyone's seen this request log or some version of this, right? You've got a timestamp, you've got your HTTP verb, you've got your endpoint, you've got your response code, maybe some extra data that you threw in there, right? Hopefully it's in structured format, not just in like plain text like this, but at the end of the day, this is actually one of the most valuable things that we can emit from our applications. So actually, now it's a little more valuable, right? If we throw a duration on there, all of a sudden we can use this to measure latency. So now not only do we understand what was happening and in what order, but we're starting to get some performance metrics there. That's really useful, right? And then, oops, wrong direction. Once we have that, we can start to build this, right? We can count things. We can count the number of times we saw a certain response code. We can do histogram buckets based on the latency. And we can start to put together what are called RED metrics, right? Requests, error, durations. Those are your most critical metrics that you want for every single endpoint in your system. Anything that exposes an API endpoint, you want to know how many requests was it handling, what percentage of those led to errors, and what was the average or P99 or whatever, right, percentile duration of the request. That's like the bare minimum information that you need in order to understand the health of your overall system. And it all comes from that really simple request log that we saw on the last slide. So logs are really, really powerful, but we can make them even better. And that's kind of what I'm going to be talking about. So if we look at it again, right, let's throw in a request ID, right? We want to think about things from the point of view of the user experience. So we come up with some request ID for the most external endpoint that the user or the front end is hitting, right? And we throw a request ID on there. So I worked at a startup in 2016 where we thought this was like revolutionary. Like, we're going to put this request ID in every single log, and we're going to come up with this system for persisting this request ID to the downstream systems, so that even the downstream systems can be correlated with that end user request, right? This is getting to a point where we can start to see a picture of everything that happened in responding to one specific user action. That's really powerful, but there's a piece that's missing still. We don't know from this necessarily the order in which things happened, right? Like we have timestamps and we can kind of try and piece that together based on the timestamps, but that's imperfect. We don't know what called what and the direct chain of events. So we can make this even better by putting a trace ID and a span ID on each one. So this is really all that a distributed trace in OpenTelemetry is. It's just a fancy structured log message that has an ID, a span. It has an ID for itself, the span, right? So the span is the thing that happened within this specific service. The trace is all of the spans that made up that one request, end user request, right? And so each span has an ID, and it has the ID of its parent, and it has the ID of the overall trace that it's a part of. And it has a duration. That's it. Those are the only things you need to transform a log message, a request log, into a distributed trace span. Then you get backends that can start to piece things together based on these IDs and give you really nice waterfall views that kind of look like this. So now we know exactly what happened, in what order, caused by what, how long it took, and how often it errored. This is starting to be, right, like this is starting to do a lot of that work for us when we were at that first slide of just trying to figure out what to Google. Well, now we kind of have like tree views and maps and topologies that can help us zero in on exactly what the problem was and find exactly the log message that has the error message in it that we need to go type into ChatGPT and ask for help. Now, I'm going to be talking about how awesome distributed tracing is. It's important to understand, right, the goal here is not distributed tracing. The goal is still to debug our applications and to understand what's wrong with them. So observability is not really any one signal. Right, the term observability kind of comes from folks who worked in Google SRE. And the way that they did what I'm talking about was just by having so many metrics and such a powerful tool for correlating the metrics that they could start to kind of get this picture from those metrics. But that's not really an effective way for us to do it today. Let's talk about the fundamental characteristics of each one of these signals, right? To me, metrics, their fundamental characteristic is that you can count them and do math with them. That makes them really useful as an early warning system, right? Like I have these range of values that I expect, and if the range of values coming out of the system is within the range that I expect, then I can say that things are healthy. So metrics kind of tell you, is there a problem or not? Traces, as we've been talking about, the main difference between traces and log is that they have that request scoped tree structure that we were just looking at. That's really valuable for connecting everything in the trace back to the end user experience. It makes them really, really useful. And then log messages are still, right, at the end of the day, every single debugging journey is going to end with a specific log message most of the time. That's where the actual verbosity and final information that you need lives. One thing about metrics, the way that metrics are used today in most observability tooling, right, like Prometheus is probably the de facto standard for metrics. It's all pre-aggregated, right? So even when we're talking about like libraries that do those RED metrics, those request error duration metrics, they're pre-aggregating it at the source, meaning your service is responsible for emitting just a number as a time series of how many things happened, which is fine if you know ahead of time which things are interesting to you and which things you want to count. But I would contend that what's even more valuable is being able to just take those traces, put arbitrary metadata on them with any range of cardinality, ship those off to your backend, and then post-aggregate your metrics based on whatever dimensions you decide that you care about or that you want to alert on. And this is maybe a more powerful paradigm that we have access to now because we have more powerful databases that can actually store every single trace span coming out of our systems, rather than doing complicated sampling and trying to discard some of them and keep track of ratios and things like that. So I think all of these signals are powerful, but we don't necessarily have to use them the way that the tools that exist today say that we have to use them. At the end of the day, this is my definition of observability. This is what I've been trying to get across, right? It's just, can we see what's happening within the system? And on seeing what's happening within the system, can we understand why it's happening? And more importantly, right, can we use our control levers to change it in the way that we desire? So it's about being able to answer questions, right? What did the user experience? What does my team have control of that was part of that experience, where it's my area of responsibility that contributed to that experience, right? What was the state of the system? If you're like a sysadmin or in DevOps, right, you're gonna have to look at the underlying metrics from the system. This is one of those cases where actually pre-aggregating metrics makes a lot of sense. You always want to be emitting like your CPU and memory things just as metrics, as time series. Although you can also put those as attributes on your trace spans. And then you can do a query like, hey, show me all my trace spans where the CPU was over 70%. Did that affect the duration? Maybe, maybe not, right? So yeah, we need to understand the state of the system. And then we need to understand the external factors, right? Like, were there other processes running on that system? In Kubernetes, were there like other pods or other tenants that might have been constraining the I/O or doing other things that would have affected that experience, that would cause outliers where like we normally see the system operating in a certain way, but based on some very unique specific combination of tags, we're seeing problematic behavior. And I think that even though I said just, observability is not any one signal, I think what I'm trying to say here today is that distributed tracing is kind of the killer app for answering all of those types of questions. It lets us understand the complete flow of a request through our system. It lets us create if we take all of those waterfall views and start to aggregate over those, all of a sudden we have a real-time map and a topology of every service that talks to every service's partners that it talks to within our system, and we can create a real-time topology that's up to date based on real traffic. And we don't have to ask the senior architect, does this service ever talk to this service? No, just go look at the topology. And guess what? It's never gonna lie to you because it's based on unsampled actual network traffic. That's pretty cool. We can, as I was talking about, we don't have to rely on pre-aggregating our metrics. If we have all of these high cardinality wide events, we can post-aggregate our metrics and count things based on dimensions that we didn't necessarily know we cared about when we were setting up our artifacts, when we were deploying our code. And finally, logs are way more useful if we can find them. And finding them is a lot easier if they're attached to a trace span, so we know exactly what part of the user experience that log message was connected to and that, the operation that log message is describing. So I think distributed tracing is really, really powerful. It's also really hard, Distributed tracing, as I mentioned in 2016, we thought we were geniuses for propagating this request ID through our whole system. That whole system used one messaging queue and one programming language. At the time we were using Elixir. But that's a pretty homogeneous environment for us where we were just trying to, and we had complete control over every step, And it was still a challenge for us to get that request ID propagated successfully. So this is not easy. And it's especially not easy once we start to introduce multiple programming languages, multiple teams, multiple environments. And this is why we now have the OpenTelemetry project. So before OpenTelemetry, this challenge of distributed tracing is really, really hard, was solved by vendors. I used to work for one of them, and they all had their own proprietary SDK that you would use to do distributed tracing and to do this context propagation from service to service. OpenTelemetry gives us a vendor-neutral way to do that. A lot of people might tell you that the vendor neutrality means, you can switch vendors, You just put your OpenTelemetry code in and then you can switch whichever backend. I can go from Datadog to Dynatrace to New Relic and it's just gonna be seamless. I disagree with that. It does make it easier, It's a lot nicer if you are going to switch vendors that your blast radius doesn't include every single artifact that you have deployed. But at the end of the day, what's really, really powerful about the vendor neutrality of OpenTelemetry is that you can use all of these tools at the same time, You have one stream of data emitting your telemetry, you have one SDK to embed in each artifact, and then if one team is we really love Grafana, we want everything in a Grafana dashboard, they can have that. And if another team is we are just addicted to Datadog, we don't care how much it costs, they can have that too. And everybody can have what they want, which is really, really rare in this field, And it's also rare that we have this format compaction, which OpenTelemetry has actually provided by bringing together two formats, OpenCensus and OpenTracing. And now even Prometheus, Prometheus, the de facto standard for metrics, it's not co-opted with OpenTelemetry, but it's sort of co-evolving with OpenTelemetry so that the standards are interoperable and compatible. This is awesome, and it doesn't happen often in our careers. This is really, really cool. So, okay, what is actually OpenTelemetry, This is the meat and potatoes. We're going to talk about what it actually is, how it works. So, at the end of the day, the first way that you're probably going to interact with OpenTelemetry is through the SDKs. So these are this is the state of the signal support by SDK by language. And it's evolving pretty quickly, logging was just sort of formalized as a signal type at the very, very end of 2023. And so those libraries are sort of still reaching stability. Tracing is extremely mature, and metrics is mature in the most common languages. If you'd like to contribute, all of these SDKs are open source, and they would love to have your contributions. But what actually is OpenTelemetry beyond the SDKs? Because it's actually a lot more than just the SDKs, We've been talking about all of these different things. So we've got the specifications. One of the most important specifications for what we're talking about is the W3C trace context. So this is actually the specification for how those trace IDs get propagated from service to service. And it's just via HTTP request headers, So you just put your span ID and your trace ID in a request header, and whatever you're calling just needs to know how to pull that out, use it to annotate its own spans that it's emitting, and then also include its own span ID and trace ID in any outgoing HTTP calls that it makes to a downstream service. Right? So each service is responsible for emitting its own telemetry. It just gets the context of the trace from the service that called it. And that's the W3C trace context specification. Then we have the language APIs. OpenTelemetry calls these the APIs and the SDKs separately. So that's the reason for that is if you are the vendor providing a library, for example, right? Like say you make the Express library, right, for Node.js. Your library can make calls to the API functions that have a no-op implementation. So anyone can safely just run that, and even if they don't have OpenTelemetry hooked up, it'll just do nothing. And then once they provide an OpenTelemetry SDK, all those no-op calls turn into however they configured in their environment, this is where I want the telemetry to be sent, right? So you kind of have these two layers, one layer for the library and one layer for the actual instance and implementation that's connected to that end user's telemetry pipeline. Then we have OTLP. This is the wire protocol. It's, you can send it over HTTP or gRPC, but it's a specific wire protocol for transmitting all of these telemetry signals, the three that I talked about, and then also profiles and events are sort of the two new experimental signals. Profiles would be for like hardware, like profiling a JVM, right, in detail stack trace on one system. And then the semantic conventions are really, really important. This is where, right, like Prometheus and OpenTelemetry are co-evolving because naming things is actually really, really hard. And if we want those reliable metrics, if we want those reliable counts, it's actually important that we always, consistently use hyphens or dashes or, right, like host CPU versus just CPU usage, right? Like all of these names have to line up. So semantic conventions means you don't have to think about it too hard. Just go look at the semantic conventions. They're very well defined for most of the types of things that we deal with on a daily basis, right? Like HTTP calls, database calls, messaging queues. All of these things have conventions that we can just use the standard and then know that it's going to continue to work with whatever tool we send it to, and that we're going to have consistency across our entire organization. Okay, so we talked about the language SDKs, right? Those are the things that you plug into the APIs that actually hook it up to exporting telemetry somewhere outside of your service. And then we have instrumentation libraries. So those also go in your code, and they connect those APIs to the libraries like Express, right? So say Express doesn't have built-in OpenTelemetry calls, but I as a user want to provide a library that anyone could run alongside Express, and it just watches Express and then emits telemetry for it. And there's lots of different methods for how that works depending on the programming language that we're talking about. Sometimes it can happen in the runtime, sometimes it has to happen before compilation. That's a whole topic for another talk, right? But basically, look for the instrumentation libraries that line up with the libraries that you're using in your code, and you'll get a huge head start in doing all of the things that we're talking about. Then there's the collector. We're going to talk about this more in depth, but basically this is your node agent or your cluster agent that gathers all of the telemetry locally on the node from all of the services running on that node, and then forwards it out to your backends or backends, plural, right? And we're going to talk about that a lot more. There's the Kubernetes operator. This is just an operator that's capable of deploying the collector, and it also has a mutating webhook that you can use to add automatic instrumentation to some services. I think it's supported in like JavaScript, PHP, Java, Python, and .NET, I believe, are the ones that it supports. And so what that means is you can basically just say you have the operator running, and you have an auto instrumentation resource that says, I want you to instrument anything that matches these tags, right? And then you deploy a new Python application that has no instrumentation in it, and the operator is just going to wrap it with instrumentation. And all of a sudden you have an instrumented application. It's very, very powerful as a starting point. It's not something that, it's not complete, right? It's not going to give you end-to-end tracing out of the box. It's not magic, but it will give you a huge head start, and then you can kind of start to find the gaps and fill those gaps yourself. Okay, and then the last part of this, right, is this is a community project. This is an open source project. It is the second largest project under the CNCF after Kubernetes by number of commits and by number of contributors. I think this kind of makes sense because it touches something, right? Like OpenTelemetry touches something that all of us do. We all interact with observability and these topics in some way, no matter what tech stack we're using. So it kind of makes sense that we would have the second largest number of contributors to the project. It's events and meetups like this one. Thanks for coming. And there's also a bunch of like online communities that you can join. These are called working groups or special interest groups. The end user working group is a really interesting one. If you're just interested in using OpenTelemetry and you want to see how other companies are using OpenTelemetry, definitely go check out some of their past recordings. They do great like interviews. They do Q&As. So yeah, that's a great place to get started. And then if you have a specific interest, say like in telemetry for PHP, you can go join the PHP special interest group and see what's going on with that, what's coming down the pipe, and you can help contribute. There are a ton of these. If you just Google like OpenTelemetry community event calendar, I think there's a GitHub page that will have like a list of all of the meetings for all of these, and you can see which ones you want to join. Okay, so how does this all come together, right, in our systems? This is a lot of stuff that we're talking about. Let's bring it all together. So we've got our service, then we've got an OpenTelemetry collector, and then we've got somewhere to send it all. Now, very explicitly, the OpenTelemetry project does not include anything for this last step, right? The OpenTelemetry project is made by a collaboration of observability vendors, and they would very much like you to pay them for this part. But these parts are no longer under the vendor control now, right? Like these are open source and we can take these with us anywhere that we want. And we're also starting to see a lot of open source solutions, not part of the OpenTelemetry project, but just in the open source community for handling this part as well, right? It's the wrong direction. So okay, just to kind of place everything, we've got some stuff in our code, right? That's the language API and SDK. That's the processors and exporters. So OpenTelemetry is extensible. Processors and exporters are one of the ways that we can extend the SDKs inside our services. Usually what you're going to want to use here is the batch processor, which just can write batch telemetry so that it's not emitted. You don't have to make an HTTP call for every event that happens in your system. You can start to batch them up and save some network traffic. And then you're going to configure an exporter. Usually this is going to be the OTLP exporter, right? Like if you're talking to an OpenTelemetry collector, if you're talking to most vendors, they expect OTLP these days. They used to have their own proprietary format, so you'll still see these like legacy exporters for each vendor. Don't use those. Just use OTLP. Make your vendor support OTLP if they don't. I think most of them do. And it's the instrumentation libraries, right? We talked about those and how they're useful. Give us a head start. Those are great. And then it's the manual instrumentation. I'll show a few examples of what that looks like, but it's pretty straightforward, right? Like basically we just need to annotate like the things that we care about that maybe the instrumentation libraries didn't know about, like product IDs and things like that. Then we have on our node, right, asterisk, because you might not be running this in daemon set, although you probably are. There's lots of different ways to deploy the collector, but you probably want at least one collector on every node in your cluster. That's where all the services on that node are going to send their telemetry, and then that collector is either going to send its telemetry directly to your backend, or maybe to a pool of collectors that are sort of acting as a proxy for your backend. Okay, and then the collector specifically has way more plugins than the SDKs, but they're in the same format. We have receivers. The SDKs don't have receivers because they are instrumentation, right? The collector has receivers, processors, and exporters. So we'll talk about what each one of those does in a moment. The collector is where you gather all, right? We were talking about how we need to know what's going on inside the host. The collector does that, right? So it has receivers and it kind of acts like a vendor agent to get metrics about what's happening inside the host and to get logs that are specific to the host, not specific to a service. And then we have the automatic instrumentation, right? Like we're using the Kubernetes operator or something that lives on the node. I see phones up, so I'm just gonna leave this slide up for a second. Okay. Okay, so here's like kind of putting all of that together in that diagram that we were looking at before. And one of these things is not like the other. I work at Altinity. We're just a database, right? Like we're not a whole backend. But Datadog, right? Like, yeah, they're the biggest for a reason. They're a great tool if you want to use it. Dynatrace, but there's a ton of open source tools that I was mentioning too, right? Like the Grafana stack. Koru is one that I'm a really big fan of. Yeah, so there's tons of stuff that we can send here. But let's talk about this side, right? So we have all those things inside our service. We have the manual instrumentation. We have, this is kind of hard to read. All right, so let's just talk about this. Receivers, processors, and exporters inside the collector. So receivers can be either push or pull based, right? You can have a receiver that works kind of like a Prometheus scraper where it's reaching out to an HTTP endpoint and recording the result. Or you can have receivers that expose an HTTP endpoint and other things just hit it and send telemetry to it. You can make custom receivers, right? So I'm working on maybe making a receiver for ClickHouse because it stores its own trace spans inside a table. And so the receiver's job would basically be to run a SQL query to get any new trace spans since the last time it pulled. But there's tons of different types of receivers. There's over 90 of them, I believe, in the project. So you can connect pretty much anything to the OpenTelemetry collector. And then we have processors. This again, right, the batch processor is really important for managing the memory and the network traffic and kind of balancing between those two things, depending on how much telemetry you're trying to export. And then we have the exporters, and here is where you might not necessarily just use the OTLP exporter, right? Here's where you might use something specific to the database that you're trying to send the telemetry to, or the backend that you're trying to send the telemetry to, or right, you can configure pipelines with multiple exporters, as I was kind of talking about that simulcast use case. And so you can have 7 different exporters and ship your telemetry to 7 different places. And you can also use the processors. One of them is the filter processor, right? So you could define those 7 different pipelines with different rules for what telemetry gets shipped where. Maybe one destination gets everything, and another destination only gets stuff specific to the team that's using that backend. So we can kind of configure that. It's very, very configurable. And then lastly, the last type of plugin that we have in the collector is called a connector. And basically what that does is it connects the exporter from one pipeline to the receiver at the beginning of another pipeline. The most common one of these is called the span metrics connector. So that does that thing that I was talking about of post-aggregating the RED metrics from the spans. So that your services don't have to do that extra work and be configured with things like temporality and all these other things, right? Your services can just emit events naively, and then your collector can be configured to translate that into what your backend is expecting. So what are the steps to actually using this? First step is to instrument our applications using the OTL API, SDK, and instrumentation libraries, right? Second step is to make sure that we actually captured everything to add our manual annotation for anything that the auto instrumentation didn't catch. Right? We at least want to make sure that every single HTTP call is captured. Then we might want to instrument some internal things, right? A trace span doesn't have to be for an HTTP call. You can also have internal spans like, hey, I have this function that's hitting my file system, and it's really slow sometimes, so I'm interested in measuring that and knowing how much of the time within this total request was spent inside this function that's hitting the file system. So we got to do our manual instrumentation, and then finally, right, we send it all to the collector and forward it to our backend of choice. So how do we do step 1? OpenTelemetry is really configurable, right? I would love it if this was one include. It's not. It's really configurable. You get to bring the pieces that you want and kind of configure it to do exactly what you want. So you need 5 libraries in JavaScript. That's not so bad though, right? Like this is not that bad. And then we get to do our manual instrumentation. Oh, by the way, there's a little bit missing from this, but the part that then turns on auto instrumentation in JavaScript at the next step in this file, it's like 12 lines of code, right? And you get auto instrumentation for everything that Express is doing, because this is from the OpenTelemetry demo application, which we'll talk about in a little bit, and it uses Express. So then we need to add additional manual instrumentation and context. It looks like this in JavaScript, right? It's pretty straightforward. Basically, what you need to do in whatever language you're using, you need to look up how you get that context thing, that object that's going to be provided by the SDK somehow through a function, through a global variable, or right, it's going to depend on the programming language. Sometimes it's called CTX, not context, because people like to abbreviate things. But you need that, and then once you have that, you can modify the current span or emit a child span. Pretty straightforward. Then we need to send all this to the collector. There's a QR code for a deep dive article I did on collector. Please don't read it while I'm talking, but if you want to bookmark it for later, go ahead. I kind of already covered this, right? So it does all of these things for us. One thing I didn't really cover, right? The collector is a really great Swiss Army knife. Say we have a bunch of things that aren't compatible with each other out of the box. Well, if there's a receiver for one side and an exporter for the other side, we just made them compatible. Because in the middle of those pipelines, everything is just OTLP. So any receiver and any exporter can be hooked up along the same signal type, right? Trace, metric, or log, or event, or profile. And the collector is also a really awesome node agent, right? Like I've started using it as a replacement for Promtail, Prometheus exporters, cluster agents. Grafana Alloy is Grafana's sort of fork of the OpenTelemetry collector. And it's really, really easy to use, and it is actually the designated replacement for Promtail. So if you just like want something really, really easy to get started with, I would recommend playing with Grafana Alloy. Then the collector gets configured with YAML. We all love YAML, right? And it's just, you just configure those pipelines that we were talking about. You just tell it which plugins you want to use. Now the collector, there's a couple of different distributions of it, where like I mentioned Alloy, just from the OpenTelemetry project, there's the contrib collector, which sort of includes all of those 90 plus plugins that I was talking about. And then there's the core collector, which includes none of them. And then there's the K8s collector, which includes just the ones specific to Kubernetes. And you can also build your own. So what I would recommend is for development, use the contrib collector. It's going to have the plugins that you're trying to experiment with, and you're just going to have an easier time. So for development environments, use the contrib collector. And once you know exactly what you're using and what you need, and you're going to production, build your own collector. It's not that hard. There are tons of tools online to help you do it, and you'll get something that's specifically optimized for your use case. Oops, wrong direction. Okay, yeah, and then exporters, right? Like ClickHouse, this is my favorite database. And you can send all three signals, metrics, traces, and logs, directly to ClickHouse. Most of the time when you're configuring an exporter, all you need is the endpoint and like maybe some authorization information if you're talking to a vendor or something, you know, over the public internet. In this case, right, I'm staying within my local host, so no authentication. And we're done, right? Everything's awesome. Not quite, not quite. So there are some pitfalls. The first is, we kind of talked about this, right? There's a lot going on here. This is a really, really broad project, and it's trying to solve a really complicated thing, distributed tracing, across every single programming language that we ever use. That's a huge challenge. So there's a little bit of complication, right? Like there's some ergonomics. And honestly, I think the project, considering the scope of the challenge, I think that the project has amazing ergonomics. The specifications are semi-stable. This is becoming less and less true, but like there was some brouhaha, I think early last year, about the HTTP specification, which had been stable, had like a major change. And then it became like a huge ordeal for all of the vendors who had to all of a sudden start caring about like, oh, which version of the specification are you sending me? Whereas before, that hadn't really happened to something as important as the HTTP semantic conventions. But this is like the reason that change was made is because ultimately we want these things to be stable so that they're not changing and you don't have to worry about that. But it is important probably to start thinking about like, okay, we're going to have some version tags and we're going to make sure that we're using the same version of the semantic conventions throughout our whole system. The SDKs are idiomatic to the source language. This is both a pro and a con, right? Like if I'm a Java developer and I'm using the Java SDK, I want it to use the idioms and patterns that I'm familiar with. If I'm an SRE team that's very familiar with OpenTelemetry but not that familiar with Java, this can be kind of a pain in the butt. I'm going to have to learn some Java stuff. If you're using OpenTelemetry and vendor-specific agents, I would say just don't do that, right? You're going to confuse your tools. Pick one or the other on a service or host basis and just stick with it. Don't install like the OpenTelemetry collector and a node agent on the same host. You can. You really need to understand exactly how it's working and exactly what it's emitting and exactly how your backend is going to interpret that. And then this is maybe a con, maybe not, depending on your preferences, but OpenTelemetry, unlike some other monitoring tools, has a strong preference for extremely high cardinality, right? Tag all the things. And on the flip side, low granularity. So polling every 5, 10, 30, 60 seconds instead of 1 second or less. So that has pros and cons, right? But it's also configurable. So This is the default that the tools are expecting, but you can configure it, you can make it work for you. And some of the vendors are going to support you changing this, right, to something that's a little more high granularity if that's important to you, if you need to know things are happening under 5 seconds, right? If you have a 5-second alert granularity, if you have a 5-second metric granularity, your alert granularity is necessarily going to be like at least 15 to 30 seconds. So if you have a 1-second metric granularity, then you can have alerts on the order of like 3 to 5 seconds. Sometimes that's important, sometimes it's not. And then the challenge that I had on this when I first gave this talk a long time ago was lack of examples. This is categorically not true anymore. We're going to talk about the biggest example, the OpenTelemetry demo project. So if you want to see an example, a working example of OpenTelemetry in your programming language of choice, go check out this repo. It's awesome. There's every single programming language. There's examples of any automatic instrumentation supported by that language's SDK. There's an example of that. And then there's also examples of manual instrumentation using all of the different language SDKs. And it's part of this e-commerce, oops, wrong way again. It's part of this e-commerce application called the Astronomy Shop, right? Which is kind of it grew out of the code base for Google's Hipster Shop, if those of you are familiar with that, which is sort of like a microservices demo application that Google uses for demos. So yeah, observability shop. 17 services, 11 programming languages. It's really, really cool. It comes with some monitoring out of the box so that we can actually see how some of this stuff works, right? So we have Grafana, we have Prometheus, Jaeger for tracing, and Grafana for visualizing the metrics and logs. And here we can see it's using that span metrics connector that we talked about a lot, right? That's counting all the span things and emitting your RED metrics. And then here's a Grafana dashboard showing the span metrics by service, right? So this is a great thing to have, like, as you're like, what's the overall health of my system dashboard? And there's an example of that in the OpenTelemetry demo project. It comes with Jaeger. So Jaeger is a tool for visualizing distributed traces. It mostly has this view where you're looking at a waterfall view of one specific trace and all of the spans that are part of it. But it also has a DAG view that can show you the topology. Jaeger, I think Jaeger is great in development environments. In production, if you're really leveraging distributed tracing heavily, I would look at least Grafana, if not something more distributed trace specific. Usually that's going to be a vendor, but there are new open source tools that are coming and are getting better and better every month. And here we can see, right, like this is an example of some of those custom trace attributes that you might want to consider putting into your manual instrumentation. Here, our earlier examples were in JavaScript. If you like Golang, here's an example in Golang, basically doing the same thing, setting the product ID based on a value in the request. Really important to note, don't put PII in here, right? Like, don't put anything in here that you wouldn't want to ship off to a vendor. Yeah, hopefully that goes without saying, but I'll say it anyways. Okay, so why is this awesome? Why do I love this? If you haven't gotten that so far. It's the vendor neutral instrumentation, right? Like, that's the first step, is we needed things that we could put in our libraries, in our services, that was open source. And in order to do that, we needed these portable telemetry formats, right? We needed these shared formats, this shared language that they call speaking, the semantic conventions. And the benefit of that is that we now have interoperable tool chains. That's what I was saying at the beginning, right? Now we can use all of the tools that we want all at the same time. Everybody can share the single stream of data. That's really, really powerful. That's really, really awesome. And then finally, right, all of this is open source. So every time you make an improvement to one of the SDKs or to one of the instrumentation libraries, everybody else in the community gets to benefit from it. And I think that's awesome too. Thank you.